Volume integral or triple integral refers to an integral over a three-dimensional domain. This is a special case of multiple integrals. So we can determine the volume of a solid region V by using the triple integral over the region V integrated with respect to V, which means that the integrand equal to the most basic function of f of x, y, and z is equal to 1. And rewrite differential V as dx, dy, dz, or some other order of these three differentials, and let the limit of the integration represent the solid V. This will give us the volume of the solid. This is just like how we used a double integral to determine area. We can use a triple integral to determine volume. And remember that there are 6 possible orders of integration because there are 3 differentials. So here we have an example. Determine the volume of the solid bounded by y is equal to negative 2x plus 4 and z is equal to 3, with x, y, and z greater than or equal to 0. So first we have to determine the limits of the integration with respect to x, y, z as well as the order of the integration. We have already plotted the following in the xy trace, xz trace, and the yz trace. So in the xy trace, where z is equal to 0, we have y is equal to 4, and then x2, and then we have this two-dimensional area over here in the xy trace. So in the xz trace, we have y is equal to 0, we have z is equal to 3, and then x equal to 2. So this two-dimensional area here will be in the xz trace. So in the yz trace, we have still z is equal to 3, and then y equal to 4, since x is equal to 0. We will get the limits of our integration on what we have plotted. So if we integrate first with respect to y, the limits of integration must be in terms of x and z, since the equation y is equal to negative 2x plus 4 is already solved. Let's start with differential y. Since the equation y is equal to negative 2x plus 4 is already solved, let's start with differential y. We have dy with the limits of 0 to negative 2x plus 4. And the order of the two differentials doesn't matter, so let's write dx dz. So the limits for differential x is 0 to 2, and for the differential z is 0 to 3. So we integrate first with respect to y, then we evaluate this at the limits of integration. So we have is equal to this. We have negative 2x plus 4 dx dz, and then integrate with respect to x. We'll have is equal to 0 to 3 negative x squared plus 4x with a limit of 0 to 2 dz. which is equal to 4 dz. And then we integrate with respect to z. We have is equal to 4z with a limit of 0 to 3, which is equal to 4 times 3 minus 0 is equal to 12 cubic units. So this will be the volume of our solid. So we have the second example. Determine the volume of the solid in the first octant bounded by x plus 2y plus z is equal to 6. So first we have to determine the limits of the integration with respect to x, y, and z. We have to graph the following in the xy trace, xz trace, and the yz trace. To determine the xy plane, we set z is equal to 0. So the equation would be x plus 2y is equal to 6. So the x-intercept will be equal to 6. And the y-intercept will be equal to 3. You have to connect. So because we are in the first octant, the x and y-intercept are positive. So this will be the two-dimensional region of the xy trace. So for the xz trace, we set y is equal to 0. We have the equation x plus z is equal to 6. So both the x and the z-intercept will be equal to 6. So this two-dimensional region will be the xz trace. While in the yz trace, we set x equal to 0. So the equation will be 2y plus z is equal to 0. So the y-intercept will be equal to 3. And the z-intercept will be equal to 6. So this two-dimensional region here will be the yz plane. So based on the traces, we can use any of these three in the order of integration. But we'll start with x. So we have dx with the limit of 0 to 6 minus 2y minus z. So, and then dz with the limit of 0 to 6 minus 2y. And then lastly, dy with the limit of 0 to 3. So first, we have to evaluate with respect to x. So we have x with the limit of 0 to 6 minus 2y minus z. dz dy. So we have to substitute this to the x. We have 6 minus 2y minus z dz dy. So we have to treat x and y as constant. So we have is equal to 0 to 3, 6z minus 1/2 z squared minus 2yz, the limit of 0 to 6 minus 2y dy. So substituting this to the z, so we have 6 times 6 minus 2y minus 1/2 6 minus 2y squared minus 2y times 6 minus 2y dy equal to multiplying 36 minus 12y minus 18 plus 12y minus 2y squared minus 12y plus 4y squared dy. Combining like terms, we have 18 minus 12y plus 2y squared dy. So integrating, we have 18y minus 12y squared over 2 plus 2y cubed over 3, the limit of 0 to 3. So substituting 3 in the equation, we have 18y minus 6y squared plus 2/3 y cubed with the limit of 0 to 3. So we have 18 times 3 minus 6 times 3 squared plus 2/3 3 cubed. This equation will be equal to 54 minus 54 plus 18 minus 0. So the answer will be 18 cubic units. So this will be the volume of the solid.